All right, so we are going to be proving that the derivative of cosine of x is equal to negative sine of x. Okay, a little bit of background here, not much. I'm not going to give you all the background because the other background pieces are in the sine, the proof of the derivative of sine. So if you haven't watched that video yet, you might want to watch that one first. But the one new thing is that cosine also has an angle sum formula. And that one is stated that cosine of x, the first term, is going to be multiplied with cosine of the second term, delta x, and then it's going to be minus instead of plus sine of x times sine of the second term. So that's an identity that we're going to be using for this proof. So without any further ado, here we go. So let's say then, for instance, that f of x is equal to cosine of x. I want to prove that f prime is equal to negative sine of x. Oops, too far. Scroll down a little bit here. Okay, so using our limit definition of a derivative, the derivative then is the limit as delta x approaches 0 of our function, which is cosine of x, but it's going to be x plus delta x for the first piece, minus cosine of x all over delta x. And just like with the sine proof that we did on the last example, we're going to apply the identity first. So if I apply the identity, it would be cosine of x times cosine of delta x minus sine of x times sine of delta x minus this last term up here, which is cosine x all over delta x. All right. So I'm going to group this expression with this expression. I'm being inconsistent with my parentheses. You don't really need the parentheses there. Then we're going to have minus cosine of x. Got a little lag, just a moment. And then this other portion here, I will now move to the back. And like I said, I want to think of these two as a group, and this is a group. And in fact, I'm just going to go ahead and use this step as an opportunity to also split it up into two separate fractions as well. Like so. All right. Next, I'm going to factor out the cosine x in my numerator here. And if I do that, I get the following. And here I'm going to pull this sine x out of the numerator, and we'll group these two together. And then we're going to apply the limit here. If I take the limit of the cosine delta x minus 1 over delta x as delta x approaches 0, that portion becomes 0. And then we have cosine x. And if I apply the limit to this piece over here, we have minus sine x. The sign doesn't change because it has no delta x. And the limit of the sine delta x over delta x is 1, as we previously mentioned. This goes away, and we are left, therefore, with our final answer, which is the fact that f prime of x is equal to negative sine of x.